Good afternoon, good morning, people. Welcome to the PAS BA Marathon. Our first session today is presented by Chris Webb, and we'll be on creating amazing 3D topographic maps in Excel with Power Query, Power Pivot, and Power Map. My name is Jody Roberts, and I will be your moderator for the day. So any questions, pop them in the question window, and we'll answer them. Questions will be answered. Please try and keep your questions to the end of the session. We'll have Chris present for 45 minutes, and then we'll have about 15 minutes for Q&A. If you need, Chris, if you can go to the next slide, please.
Cool. Yep.
So if you require any technical assistance, please type your questions into the questions pane located on the right side of your screen, and someone will assist you. The question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get the Q&A portion of the session, I'll read the questions aloud to the speaker. You are able to zoom in on the presentation content by using the zoom function, the zoom button located at the bottom of the presentation window. Note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear in your web browser. Next. If you like what you hear in these seminars, in these webinars, make sure that you attend the PAS Business Analytics Conference taking place from May the 2nd to the 4th in San Jose, California, with hands-on learning opportunities from data to business analytics experts and a variety of networking opportunities. The PAS Business Analytics Conference is a great opportunity to gain valuable skills and advance your career. Next. So if you're interested in accessing free educational content, the PAS organization has a variety of virtual chapters which offer free webinars to their members every month. Check out the upcoming webinars and recordings of PAS webinars from our Business Analytics, Excel BI, Business Intelligence, Big Data, and Cloud virtual chapters by visiting www.sequelpas.org/VC. And next, about our speaker. So this BA Marathon session is presented by Chris Webb. As most of you know, Chris is a legend in the BI world. So we look forward to hearing from you, Chris, and what you present.
Cool. Thank you, Jody. And thank you, everybody, for coming to listen to my webinar. So I've got an ambitious topic, amazing 3D topographic maps in Excel. What are we going to learn in this session? Well, we're going to have a lot of technical content. So first of all, I'm going to explain where you can get the data for these amazing 3D maps that I'm going to show you how to build. This is based around something called LiDAR data. We're going to spend a lot of time looking at how you can import and prepare this data with Power Query. Then we will see how you can display the data with Power Map. And then finally, we will wrap up with some discussion of practical applications for this, and also an example of something that I think could possibly be a practical application for this. But before we start, there is one thing that I wanted to say. Now, the title of this session is obviously Building Cool 3D Maps, and I promise I will show you how to build cool 3D maps. But some of you might be thinking, that's all very well, but really, honestly, my scope for building cool 3D maps as part of my work is very, very limited. So what am I really going to learn from this session? And if I'm honest, my scope for using cool 3D maps in my work is actually very, very limited as well. But I would like to justify myself by saying one thing. What I find is that when I'm learning a new technology, there are two ways that I can learn that new technology. Now, I'm a consultant, and one way that I'll learn a new technology is have a customer call me up and say, hey, Chris, I want you to come and help me with new technology X. Please can you come in next week and tell me about it? And then, like all true consultants, I panic and I think, wow, I really must get to learn this new technology properly, and I sit down and I go away and learn it. Now, that is obviously not an ideal situation. So what's preferable is the other way of learning the new technology, which is sitting down when it becomes available and making myself learn it in my own time. But like a lot of people, I have a lot of trouble motivating myself to do this. So how can I actually motivate myself to learn effectively? Even if I've got the time, quite often I'm sitting there thinking, well, you know, maybe I'll just check my email one more time or read that blog post or do something else instead. So motivation is key to learning some new technology. And what I find is that if I can find some cool data and, you know, a fun, albeit in a geeky fashion, project, then I'll have a lot more motivation to learning new stuff. So if you think about it, okay, cool 3D maps, yeah, that sounds like a lot of fun. Maybe not practically useful, but actually, if I find a nice, you know, a cool application like building 3D maps, it's actually going to motivate me to learn Power Query and Power Map even better. So in fact, doing something like this, making yourself engaged, is actually a really, really effective way of learning what will be practical skills, practical Power Query and Power Map skills, even if you don't end up using 3D maps. So what we'll learn, or what you'll hopefully really take away in terms of practical usefulness from this session, are some really useful tips, mostly for Power Query, probably also for Power Map as well. And these tips will also be applicable to Power BI as well, because of course, if you've used Power BI, you will know that the get and transform bit of Power BI is effectively Power Query, and Power Map is possibly coming to Power BI soon. There was a 3D Maps custom visualization that got released for Power BI the other week, but that's not really Power Map, and it certainly wouldn't be able to do the things that I'm going to show you in Power Map today. But there were stories on Twitter recently that you know, some kind of integration between Power Map and Power BI will be coming soon. So hopefully then you'll be able to do everything that I show you here in Power BI. So let me tell you a story. Let me tell you how I came to decide to want to be able to build 3D maps. So a couple of weeks ago, it was Sunday evening, and my wife was watching some rubbishy American cop show TV that she likes, and I was sitting there feeling, well, you know, it's a little bit dull. I could watch this, but you know, maybe I'll just switch my PC on. You know how it is. And I was reading some blog posts. Now, there is a guy that I follow on Twitter in the UK, and if I go back to here, so there's a guy called Owen Boswather who blogs a lot about open data in the UK, and this was the post of his that I saw. So here, he was posting about some stuff called LiDAR data. Now, what is LiDAR data? So LiDAR data, it turns out, stands for, or LiDAR stands for Light Detection and Ranging. So the UK government, specifically the UK Environment Agency, flies drones and helicopters and planes all over the UK and uses LiDAR to scan the surface of the country. So what we get is not just a 2D map of the country, but actually a genuine 3D map of the surface of the UK. I believe we actually have now got the whole of the UK. Certainly, I'm sure you can get it for England, and I believe in some other places you can get it for Wales and Scotland. I'm not sure about Northern Ireland yet, but I also believe, and I'm not sure, but I believe that other countries do this and make it available as open data. So for example, I've heard Spain and the Netherlands do this. You might want to check your local government open data initiative, if there is one, to see whether you can get hold of this data. So for my purposes, what I'm doing is I am going to this website, so environment.data.gov.uk. I will make the slides available afterwards if they're not already available, and the URL for that's here. And in order to find some data to download, we have a map. You can scroll around on the map, and then you can zoom in. And if we zoom in, for example, on central London, you can see that the UK is divided up into these squares. Now these squares are 10 kilometers by 10 kilometers, and if we zoom in a little bit more, what you will see that they are divided up into 1 kilometer squares as well. So you'll be able to see maybe some of these faint, what color are they? Blue lines going across the map here. So you find the area of the UK that you're interested in, and let's say we're interested in central London, and then down here you can choose the type of data to download. So you can download a zip file containing one of these, all of the LiDAR data, basically a series of files that contains 3D scans for the surface of the UK in 10 kilometer square chunks. Now you've got two choices here, and this is something to be aware of. You have digital terrain model data and digital surface model data. You've got tiles apparently, and this is older data that I haven't played around with. So you've got two types of LiDAR data, digital terrain model and digital surface model. All of my sessions, or all my demos, are going to use digital surface model data. This is the data actually as it is scanned. So this is going to show you everything on the surface. If you get the digital terrain model data, what you get is the surface with an attempt to remove all man-made objects. So what they do is after they take the scan and they've got the digital surface model data, they then try and process it to remove buildings and bridges and cars and whatever else is picked up. Obviously, the digital terrain model data is going to be more useful if you're perhaps looking at engineering applications or you want to see the actual surface of the ground. For my purposes, where I'm more interested in doing cool demos and showing stuff, the digital surface model data is more interesting. So we want the DSM data, then we have a choice. The DSM data comes in a variety of resolutions, and we don't have every resolution for every square of the UK. So if you want to see coverage, you could maybe choose to see the data at 2 meter scanning resolution. So if I do this, it will actually cover the areas that we've got data for this 2 meter square resolution. And we've got a variety of resolutions. We can look at the data at 2 meter square resolution, 1 meter square resolution, and 50 centimeter square resolution. I believe it's also possible to get it in 25 centimeter square resolution. I'm going to be using a mixture of 1 and 2 meter square resolutions here. The 50 centimeter square resolution results in a lot of data, and what I found is that on all the PCs I own, I'm not really into gaming, I don't have very good graphics cards, and the amount of data to display is simply more than my graphics cards can possibly handle. So you choose your resolution and then you can just download. And what you get is effectively a zip file containing a whole bunch of ASC files. So for example, if we look inside this zip file, this is the zip file showing the data for that central London square that I was looking at in 1 meter square resolutions. And each one of these files represents an individual 1 kilometer square section of that larger 10 kilometer square area. So we've managed to download our data. How can we actually do something useful with it? So what this data is effectively a series of coordinates plus a height. So it's actually a 3-dimensional coordinate. So you're going to have an X, a Y, and a Z. And I looked at this data and I thought, wow, I bet I could plot that on a custom map in PowerMap. So I downloaded the data and then I thought, well, okay, what I need to do is to be able to import the data from these text files using Power Query and get it into the right kind of format. So the first question to answer is, what is the right kind of format that I need? You know, if I'm transforming this data, what should my output be? Well, let me give you a nice simple example. What I've got here is a simple Excel table that I've just typed some numbers in, you can see we've got x coordinates and y coordinates, and we've got 3 values on the x-axis, 3 values on the y-axis, and then we have some heights. And then if we go to Power Map, or rather I'm using Excel 2016 because of course in Excel 2016 Power Map has been renamed 3D Maps, but I still prefer the Power Map name. I'm going to open Power Map, and let's have a look at what this simple data looks like plotted on a map. So we've got an x-axis, we've got a y-axis, and we've got a height, and there we go. You can see hopefully those 9 points plotted on a custom map. I'll go through how to actually prepare the custom map we need for our real scenarios a bit later. But you can see we've got 9 points with various different heights plotted on a map. And if you can imagine these points getting a little bit thicker, we'll increase the thickness a bit. You can imagine how if we have lots and lots of these points plotted on a custom map, the points can merge together and eventually we'll get a landscape coming out. So we know how our data needs to look. How can we get there? So let's have a look and see what one of these .asc files looks like. So this is one of those ASC files opened in Notepad++. And you can see that we've got a couple of header rows. We've got 6 header rows. First of all, we've got the number of columns, which in this case is 500, the number of rows, which is 500. Then we have the XLL corner and YLL corner values. This is going to be important for later on. What we actually have here are UK grid references. So the UK, as we've already seen, is divided up into these gigantic grids, and actually each one of these each point in these grids has got a grid reference. And what we've got here is for this particular square of data, the grid reference for the bottom left-hand corner of the bottom left-hand square for this particular chunk of data. So XLL corner is the X coordinate of this, YLL corner is the Y coordinate. You'll also see these referred to as eastings and northings. That's probably a UK specific term, but eastings is basically the X coordinate and northings is the Y coordinate. So you can just imagine that somewhere there would be a gigantic grid over the entire UK, and these X and Y coordinates would allow you to pinpoint an individual position on the map from them. Very similar, I guess, to latitude and longitude, but we're going to have to work with these OS grid references instead. We've also got the cell size, so this is the cell size in meters. We've also got here something, the no data value. So if we've got missing data, for example, they just haven't flown a drone over your back garden, you'll have no data there, and that will show up as a value of -9999 in this case. And then after that, we have simply got a great big chunk of figures. There are some line breaks in there, but it's a great big chunk of figures. Now, each one of these is a height. We don't actually have the X or Y coordinates from this file. We've got to derive it, which is a bit of a pain. So what we've got to do is read in this data, and the first 500 values will be the first row, after which we'll go on to the next row, read in the next 500 values, go on to the next row, read in the next 500 values, go on to the next row, and so on until we get to the end. So this is the text file format that we're going to have to work with. How can we deal with this? Well, let's go to Power Query, but again, because I'm working in Excel 2016, this should be just queries. And let's start to have a look at some code. So here I've got the beginnings of a query. And you can see that once I've connected to my text file, this is what we will see in Power Query. So the first thing that I need to do is I need to read the values in all of these first 6 rows and be able to get them, because I'm going to need to use them later on. So first of all, get those first 6 rows. We can use that using the Keep Top Rows button, and let's say we just want the first 6 rows. So bingo, we've got the first 6 rows. Now I need to separate the numbers from the values. Now there are a variable number of spaces in between here, but there's always going to be one space. So I can right click and split the column by delimiter. The delimiter is going to be a space, and I only want to split once, let's say at the leftmost delimiter. Click OK, and you can see, bingo, we've got all of our values. I could rename the columns here, but to be honest, there's not really any need to do that. Now later on inside my code, I'm going to need to be able to reference each one of these individual values somewhere. And what I can do in order to reference value inside a cell is to generate the M code to show you how to do this. Just right click on a cell, so let's choose XLL corner, right click and then drill down. So this is how you refer to an individual value in a table and get it out just as a value. So at this point my step actually returns the value 490,000. Here this is the name of the table in the previous step. So here if I go back to change type, the change type step returns this table, and what I'm doing is I'm referring to the table returned by that step, and then I am asking for the third row. So this is a zero-based array, and if I've got the third row in curly brackets, I'm going to be asking for the coordinate 2. So I'm asking for the third row here, and I'm asking for the value in column 1.2 for that third row. And I'm going to be able to create references to all of those values. Now, that's good, but this is where I'm going to need to actually go in and start to write some more code. So those first couple of steps I can do just using the UI. Actually now I need to go in and start to write some M code myself. So let's have a look in the advanced editor and see what the rest of the code looks like to load the data into the format that we want. So up until here, this is what I was able to do in the UI. Then I have a whole bunch of steps here that have got, let me get rid of that, that have got names. And you can see they've got that same set of references to individual values inside those cells. So all 6 of the values inside those cells I've referred to in steps. And when I do this, I'm going to be able to refer to all of these step names as if they were variables later on inside my code. So I'll be able to use ncols and get the numeric value from that cell later on inside my code. One of the things that you may not realize until you actually start doing some work in Power Query is that you can get hold of values like this, and the steps do not have to feed into one another. If we cancel out of this, once I've got those set of variables, I can actually then just say, well, let's get down to the raw values. So this isn't following on from anything else that's gone before except the source step. And what I'm doing here is I'm saying let's go back to the source step and get everything except the first 6 rows. So now I'm just getting those series of heights. I've got a series of lines with height values in. I split these by spaces. So I'm creating a new custom column. I'm taking all of the values in here, and in my custom column I'm getting a list, which is kind of like an array value containing every single one of those values. Once I've got that list value, I can remove the original heights. I turn that into a combined value, so I've got now a single array containing all of the height values. I just remove the no data values and replace them with an empty string, convert this to a table, and now we need to derive the rows and columns. How do we do this? So this is where we can need a little bit more explanation. I hate the way Excel 2016 just plonks these images everywhere over my worksheet. So how can we derive from a list the number of values or the X and Y coordinates? So what we've got here is a list of possible heights. We know the number of rows in our data set. We know the number of columns in our data set. How can we derive the X and Y coordinates for each cell? So the first thing we need to do is to put an index column in. So here I'm going to have a row number starting at 0, just paste that down, and I've got a row number. And from here, once I've got the row number, in order to find the X coordinate, I just divide the row number by the overall number of rows. So here, get the value, the number of columns, divide the value of the row number by the number of columns, and then round down to the nearest integer. And that will give me my X coordinates. And then to get the Y values, I just find the modulo of the row number and the number of rows. And then I do that, and I get my Y coordinates. And this is pretty much what I'm doing in code here. So if we go back to here, I've got my table, I add an index column, and then I'm going to add a series of custom columns just to derive the column number. So here I'm using the mod, and if I go down, you'll see I'm doing the number.integer divide, using the number.integer divide function to find the row number. And then finally, I'm doing some other calculations to find the actual grid reference for each cell as well. That's a little bit more complicated. And then finally, I just rename the columns, and I've got the data in the format that I want. And having done that, I'm in a good place. But I could load this into PowerMap and just look at the data. But actually, there's one more thing that I want to do, because this is going to be handy later on. Rather than have a single query where my file name here is hard-coded, so you can see here that on the first source step, my file name is hard-coded. What it's really handy to do is to take this and turn it into a function. So if I take all of this code, I can turn this into an M function. So let's create a new source, a new blank query. I'm going to paste the code for that in, and to turn this into a function, all I need to do is say file name as text, and my function is going to have one parameter called file name, and what I'm going to pass in is as text the name of the file that I want to load. And so therefore, instead of hard coding the file name here, I'm just going to use the file name parameter. There's nothing else I need to do except give this function a better name like read data. And now I'll be able to call my function and be able to load some data in. Now at the moment, I'm just going to use this same old file that I was using here. But in order to call my function, I could click the invoke button, but that actually messes up the code for my existing function. I'm going to have a new source and a new blank query again. Go to the advanced editor and just simply say read data, pass my file name in. That works. Close and load. Now I've set this not to load automatically, but now I want to load this to the data model. I don't want to load it to a table because there's going to be potentially a large amount of data coming through here. I'm going to load this to the data model. And because this is 2 centimeter square resolution data, it's going to come up with about 250,000, well, it's going to come up with precisely 250,000 rows. So we've loaded our data to the data model. So this is our raw data. It's in a format that PowerMap likes. Now we need to go to PowerMap to build our map. So I go to 3D map, open 3D maps, create a new tour. Now, when you start a new tour in PowerMap, you see the globe. I probably could try and plot this on a globe, but I'd need to convert the map reference to latitudes and longitudes. So what I'm going to do instead is say, well, rather than look at the globe, I'm going to create a custom map. So let's choose a custom map. Here I'm going to go and have 0, 0. And I have got 500 values here, 500 values here. I could use the auto-fit button to do this, but I'm going to cheat. Click apply, and now I've just got an empty square to put my data on. In terms of location, I've got a column number and a row number. So the column number I can select here, and that is going to be an X coordinate. I'm going to choose the row number, make that the Y coordinate, and for the height, I'm going to choose height. Now when I do this, PowerMap is going to go away and read all that data in. This takes a little bit of time because there's 250,000 rows to values to add in, and we see something that looks like it might be a map. There is one crucial last step here. What we're seeing is 250,000 bars plotted as like a bar chart on top of our map. And the bars here are going to make up the individual heights in our landscape. But the bars at the moment are too thick. So the key thing we've got to change here is under layer options, this thickness value. And what I've found here is if we change this to 18, and also remember to click lock current scale, what we'll actually see is the landscape in much better clarity. And now if we zoom in, you can see something resembling a landscape. You can see that we've got something that looks like maybe a road here. We've clearly got some buildings here, and we've got some fuzzy stuff, and these are actually trees. What I've actually done here is I have loaded in some data fairly close to where I live. And this is what that area looks like on Bing Maps using their bird's eye view. I'm not using this as a Microsoft presentation, but actually Bing Maps bird's eye view I found actually looks better than Google Maps for working this out. What we can see here is a section of the M40, which is like a motorway or a freeway to Americans, which goes northwest out of London. And for this section, here's the motorway. We can see some roads roundabout. We can see a distinctive shaped office building with a hole in the middle. We've got some kind of zigzag industrial buildings here, and we've got a large out-of-town supermarket here. And if we go back to PowerMap, you can see that there are those zigzag buildings. If we go over here, there's that distinctive shape office building with a hole in the middle. And over here, we've got the out-of-town superstore. So we've got something that is beginning to look like a landscape. So how can we make this better? Well, let's go to the next level on this. What we really want to be able to do is pick out different areas inside the map. And the way to do that is, of course, going to be to use color and probably also a slightly higher resolution. So rather than build a demo, I have got here another workbook that I prepared earlier. And in this case, I've downloaded a section of map for the center of London. So I'm not going to show you the code for this, but if I go to 3D Maps and open up my tour, what we'll see is the section of London, and this is at the 1 meter square resolution, so now we're going to get significantly more data than we had before, so the processing is going to take a bit longer. But we've got the section of London which includes the Houses of Parliament, Big Ben, and a section of the River Thames going past that. And if you know central London, we've also got the London Eye, the Shell Centre, and Waterloo Station there as well. So this has now got 1 million data points on it. And I'll just let this load up. It takes a little bit of time to do. And what you can see when this finally decides to appear, we've got significantly better resolution, and we can go around and we can see very clearly buildings and river. And if we zoom in a bit, you'll be able to see, for example, here is Waterloo Station. This badly defined thing is the London Eye. We've got a distinctive shaped office building again. We've got the Houses of Parliament, and we've got Westminster Abbey. But I've done better than that. What I did in Power Query here was say, well, okay, for each row, let's look at the height. And if the height is less than 3 meters, let's say that that is river. If the height is greater than 10 meters, let's say that's a building. And then for everything else in between, let's say that's ground. So I've got a category field here, and I've got that as color. Now when I choose that in category, each one of my bars is going to be in one of these 3 categories, and PowerMap is going to give that a color. This will take again a few moments to reload the data. This is always a bit time consuming. This is going to be obviously very, very data intensive, and this is the point where I wish that I had invested in a gaming laptop or something in order to be able to do this kind of demo. But it will be there in, I would say, under 10 seconds. But what we will see when we do this is that, bingo, it will be there. Here we go. So I've color-coded the river to be light blue, the ground at particular heights to be green, and the buildings to be purple, and we can automatically now see everything in a lot better detail. You will notice that some areas of ground are below the level of the river, so they appear in blue. I'm pretty sure that isn't water there. You'll see there is some what looks like ground on the river. Now actually I don't think this is a mistake. I think this is a situation where we have barges and maybe jetties going up down the river, and then finally we can see the buildings. We can see the buildings in a lot better detail. Let me show you the equivalent in Bing Maps. So here we've got the area that I'm looking at. Here is Waterloo Station. Here's that distinctive triangular type office thing. We've got the bridge here. We've got the Houses of Parliament. We have Westminster Abbey. If I swing round, you can see that we've got Big Ben here. I've forgotten what the name of this tower is, I'm afraid. But we also look up here. You can see maybe at the end of Westminster Abbey, actually it's not so clear here, there are 2 distinctive rectangular shaped towers. And we can see all of this in PowerMap very, very easily. So if we swing round now, there is the far end of Westminster Abbey and the 2 towers there. That's Big Ben here. There's Waterloo Station, and we've got quite a lot of good detail even on the roof of Waterloo Station, and there's that distinctive office building there as well. So you can see that we've actually managed this resolution to generate something that looks like genuinely a real recognizable 3D landscape in PowerMap. Of course, once we've done that, we want to go even further. What I've got here is a tour over this. I was going to spend a little bit more time showing tours, but unfortunately the problem with showing tours at this level of resolution is the tours don't really come out very well. I've recorded a tour over that very first level of data that I showed you over the rather boring section of motorway. And this is what a tour will look like at the 2-meter square resolution, which I still think is pretty good. It's quite sharp. In fact, once you've actually saved the tour as a video, you get much better resolution. And you can see the office buildings there and the road, and you can zoom in and out. Unfortunately, what I found, at least in Excel 2016, is that while you can make a tour play in the Power Map window, as soon as you try and save it to a video, Power Map decides to not work very well. So I can show you a tour here, but I wasn't able to render this to video. I suspect maybe I was running out of memory, or I didn't have a powerful enough video card. But you know, it would have been pretty cool to be able to record a video where I could zoom in and show various different parts of the Houses of Parliament and Westminster Abbey and things like that. Two more things to show to finish off. If we're being really ambitious, we might want to show more than one square of data. And this is where it really pays off to have a function rather than a individual query which is hard-coded to a data source. Because now if I've got a function, I have 3 squares of data that I've downloaded in 3 files. I can use Power Query to load the data from this Excel table, get the 3 values from file names from those values, make that into a table, and then create a custom column, and in that custom column call my function here. So this is my function which takes a file name and reads the data from it. Call it for each row on this table, and when I do that I get a nested table value in here. When I've got a nested table value, I've got the expand button here. I can expand that, and now I have all 3 of those tables of data appended one after the other into a single gigantic table. And I also need to remember to change the height and set the colors. And what I've got now, if we go to Power Map, is not just 1 square of data, but 3 squares of data, all appended one to another. And the tour here would have been particularly cool. I was really desperate to do a kind of, you know, fighter pilot type demo of zooming along the Thames and going up, but unfortunately, like I said, my graphics card really isn't up to it. Once this is loaded, and I've done this at a slightly lower resolution, so this is the 2-meter square resolution, so we've got a 750,000 data points here plotted on the map, but it's still color-coded in the same way. What we'll see here is that we've got a much longer stretch of the Thames and the buildings along it. So let's get rid of that, and now we can zoom in and see some of the larger buildings along here. Pan around, look around, there's what we had before, but now we've gone 3 squares down. We can see a larger bend in the river, and we can see a much larger section of values for central London. So that's quite fun. So hopefully now we've done something fun. We've learnt a bit of possibly useful stuff for Power Query and Power Map. What possible practical uses are there for this? Now, this data is open data in the UK, and even since it's been released, there have been people around the UK using this for practical applications. So I would imagine it would be useful for snowfall, rainfall and flood monitoring. We've been having some big problems with floods, unfortunately, in this country. I'd imagine looking at LiDAR data on a map would be very, very interesting. I could also imagine that if you had a scan of a shopping street in the middle of a town, and if you had footfall data, it'd be quite interesting to plan to be able to visualize footfall data on one of these 3D maps as well. There are obviously obvious applications for archaeology and civil engineering. I read quite an interesting case study where apparently the British wine industry, and you may not realize there is a British wine industry, and believe me, if you ever see some British wine, whatever you do, don't try it. It's pretty awful stuff. But they've been looking at this data to find optimal places to plant their vines, because apparently it has to be at a particular the ground has to be at a particular angle to catch the sun to make the grapes grow. So maybe with the help of open data, we'll have slightly better tasting English wine. And finally, I thought, well, could we use this for road accident analysis? I've already shown you a demo where we've got a section of motorway. I'm also aware from previous demos that I've done that you can get hold of all of the road accident data for the UK as open data. And interestingly, it turns out, let me open this in Notepad. So what I've done here is I've downloaded a CSV file with all of the road accidents in the UK for 2014. If I open this in Notepad, we've got one row in this CSV file for each road accident. And interestingly, we've not only got the latitude and longitude of these road accidents, we've got the eastings and northings, which are those OS Ordnance Survey grid references that we're already calculating in our previous query. So we're going to be able to take our map, we're going to match the eastings and northings that we've calculated for each one of our bars in our bar chart and match it up to road accidents. So what I'm going to show you as my last practical application, let me close that, is a rather busier section of road than the one that I showed you. So let me open 3D maps, and when that's opening and loading up, and that will take again a little bit of time, but let's switch over to here. What I've done is I've chosen this particular section here. So we've got on this map central London. The M4 is the main motorway that goes west out of London. The M25 is the motorway that goes around London, and the point where the M25 meets the M4 is here. So we've got a big motorway interchange. This is a very, very busy section of road. So there is Heathrow Airport there, and you can imagine that this is one of the busiest sections of road in the entire UK. So what I did was I downloaded all of the data for this particular tile and plotted it on a map at 2 meter square resolution in the way that we've seen before. And then what I did is I merged that data with the data from the CSV file containing all of the accidents, and then I left the regular stuff in blue, and when there was an accident, I painted a little square, a little area of my 3D map to be a particular color, and the colors vary on the accident severity. So yellow is not too bad, purple is pretty bad. I believe that might have been a fatal accident as well here. And what we can see now on this map, you can see very clearly the motorway interchange. We can see in 3D all the relief. We can see the trees around the edge of the motorway as well, and we can see clearly painted in yellow and purple all of the areas where there is an accident. And we could have certainly plotted this on a 2D map, but I think the real benefit here, when we start looking at this, you'll notice there are some strange blobs on the motorway. I think these are actually cars or lorries going up and down the motorway while it was scanned. But you can see here now very easily, probably in a way that you can't see on just a flat two-dimensional map, exactly where the accidents took place. So you can imagine maybe if there was a steep hill and there were lots of accidents there in the winter, on a 2D map, you would just see a cluster of accidents. On a 3D map, where you can see the not only the X and Y, but the Z, then you've got a much better idea of why accidents are taking place in a particular area. So here we can see, in fact, that a lot of these accidents are not happening on the main section of the motorway properly, but possibly where people are maneuvering to exit the motorway. So that brings me to the end of my presentation. Hopefully you've had some fun and maybe learned some interesting tricks, and maybe even you've got a practical application for using this LiDAR data and Power Map in your real job. If you have, I would be absolutely thrilled to hear from you. So, Jody, if you're there, have we got any questions?
Yeah. Andrew Connolly asking, what's a lorry? That's a tough, Andrew. Yeah, Artem Shevchenko is asking, what's the advantage of such a map above one that could have been in QGIS? Looks like a cool example of Excel capabilities, but no idea how to practically use it given he's outside the UK.
Yeah, so I mean, the obvious question here is you're doing this in Excel. You know, there are tools out there for there are specialized tools for putting this data on real maps, proper GIS systems. I suppose there's two answers to this question. The first is this is Excel. This is native Excel functionality. I've not gone out and used any add-ins. I've not installed anything else. I've not had to buy any external software. So if you're on a budget, then using Excel could be a nice answer here. Secondly, because we're able to manipulate the data using Power Query before we plot it, then we would be able to not only take the data and plot it on a map, but we'll be able to alter it. So for example, if you were thinking of looking at maybe river levels and you could identify the river on your map, you could maybe change the river levels, computationally alter the data so that you could see how the rising river level covers other areas of the map. And yes, you'd probably be able to do this in other tools, but I suspect doing this in Power Query is probably actually going to be a bit easier than trying to take this data, manipulate it in somebody else's code, and then import it into yet another GIS system. So maybe not the most convincing of answers, and like I said right at the beginning, maybe the real purpose of this is just to use some Power Query and Power Map tricks that you use in some other completely different area. But possibly somebody might want to use this.
Okay, and then here's another one from Matt Romney asking what Excel releases include the Power Map ability. Okay,
now this is a complicated question. I'm here using Excel 2016, and Excel 2016 has Power Map built in, renamed as 3D maps. Everything that I've done here you can do in Excel 2013 using Power Map, and indeed I built most of these demos on Excel 2013 using Power Map. I upgraded to Excel 2016 over the weekend. So everything you can do here you can do on Excel 2013 using Power Map. The frustrating thing with Excel 2013 is that if you want to use the full version of Power Map, you have to use the Office click-to-run version of Excel that's only available with an Office 365 subscription. There is a trial version of Power Map you can download, but it's not the final release version. It's a slightly crippled version, I believe, and it may not give you everything you need. So really, to use Power Map in Excel 2013, you need an Office 365 subscription, and you need to be using the click-to-run version of Excel, which in my opinion is a very sad state of affairs. Any more questions?
I'm just going through here. I've got one here, just hold. There's somebody called Ifis that says, thank you very much for the nice introduction to 3D map presentations. Is there a way, Otto was asking again, is there a way to gather such XY data if my government does not provide it?
I guess you could buy your own drone and equip it with LiDAR information. I suspect not, unless you're going to get this from a government data source.
Okay. And Sundaresh Pire is asking how much RAM in your PC.
I'm doing this on a laptop with 8 gig of RAM. And I suspect, and certainly not a specialized graphics card. Like I said, I don't actually own a proper gaming PC. I don't really play games, but I bet that if I had a gaming PC with a vast amount of RAM and, more importantly, a half-decent graphics card, PowerMap would be able to do some pretty amazing stuff with it. I bet I would be able to go down to the 50 centimeter and 25 centimeter resolution and be able to record some pretty amazing tours.
Okay, you seem to answer Stefan's question as well. Matt wants to know, how do you access the Power Map and Power Query features?
So I've got Excel 2016. In order to get at Power Query in Excel 2016, it's built in, it's on the Data tab, and it's here. In Excel 2016, to get at the mapping functionality, you need to go to the Insert tab, 3D Maps, and that's here. If you've got Excel 2013, and if you've got the appropriate appropriate version, edition of Excel, then you would be able to simply enable PowerMap. It'll be installed by default, but it's a separate add-in, so you need to enable it. In order to use Power Query with Excel 2013, that's a separate download. So you need to bingle for download Power Query, and you'll be able to download it and install it for Excel 2013. Power Query is available for Excel 2010 as well, but PowerMap is not available for Excel 2010.
Okay, then Fabiola is asking, how do you assign the color for the building?
Okay, so in terms of the color, all I did was, like I said, use a very, very simple expression. So if we go back to my original London demo, and we go back to the colors, all I was doing was literally doing a simple conditional expression based on the height for each coordinate. So if we go here and edit this query, the expression I was using was literally, if height is less than or equal 3.5 meters, then river, else if height is greater than 10, then building, else ground. And then in PowerMap, I made everything that was river blue, everything that was building purple, and everything that was ground green. And you can assign those colors pretty easily. I did show how to assign the colors. I think, oh no, I probably didn't show how to assign the colors because they were already assigned. But if we go back and insert and go back to my 3D maps here, you will see that if I take this particular thing and we go to layer options for each individual, so if I was to go and add color as a category here, let's hide that and let's hide that. What you'll see is that when this loads up in about 10 or so seconds, you'll be able to choose each category, so river, ground, building, and you'll be able to assign it a color down here. So I'll not wait for that to happen, but hopefully you can imagine that when I've loaded up these values, you'll be able to see the individual category values that I calculated in that column in Power Query, and you can assign them values here.
Okay, and we've got one last one from Alex. Why was an index array required to build a topographic map?
Why was an index array required? I'm not sure I understand the question, I'm afraid. So what I needed was simply just a table of data, and it's a table of data that I loaded to the Excel data model. So I showed you what that looked like in Power Query. If we go to the Data tab and have a look at the data inside the Excel data model, what people might call Power Pivot, then you can see here, this is the table of data that came back. So there's my column number and row number and height and various other columns that I was using there as well. So I needed a table because that's what Power Map expects. I couldn't just use that list of heights. I needed to be able to derive the X coordinate and the Y coordinate in order to be able to plot that on a map in Power Map.
Cool. And then Brian is asking, any chance you could pull up the end code for the first demo again on the screen? There were some great tips there for pulling out parameters from header rows.
Sure. There is an older version of this available in a blog post that I wrote about a month or two ago. I need to update it because I found a bug calculating the actual OS grid references. But here is an example of the final function for the code that I was using. But certainly you'll be able to download this from my blog, or if you drop me an email. My email address is chris@crossjoin.co.uk. I'd be happy to share the code with you and answer any questions. And certainly, if anybody does have any more questions, feel free to drop me an email.
Cool. So we have to wrap up now. Thank you guys for attending. The next session is module data extraction and integration patterns by Ken Ritz. So yeah, please join us for the next session. Thank you very much, guys.
Thank you. Bye-bye.
Bye.